High School, Agulu, our alma mater grace. Our great alma mater and our pride. Rosa Mystica High School, Agulu, the home of discipline. Our noble alma mater, we are proud of you.
Good day, my wonderful students at home. Welcome to this class. Today, we have physics, SS2, and the topic is light wave. But before we go into the specific objective, I would like to ask you the following questions based on our previous topic, wave. I hope you are with your writing materials so that you can put the following questions down and answer them while I give you the correct answer. 1. Define wave. 2. Give 2 types of wave and explain them. 3. List 5 properties of wave. 4. Define 5 terms you can use to describe wave. I hope you got the questions. I believe that by now you might have been through with the answers. So I will give you mine so that you can cross-check and assess yourself. Number 1 question. Wave. Wave can simply be defined as a disturbance that travels through a medium, transferring energy from one part of the medium to another without causing any permanent displacement of the wave itself. Wave is a disturbance that travels through a medium, transferring energy from one part of the medium to another without causing any permanent displacement of the medium itself. 2 types of wave. We have mechanical waves and the electromagnetic wave. Mechanical waves are those waves that travel through a material medium. We can have examples of mechanical waves like water wave, sound wave, wave generated on string and loop. Electromagnetic wave is a wave that does not require material medium for propagation. Examples are light wave, radio wave, X-ray, infrared, and so on and so forth. 3. Properties of wave. We have 5 properties of wave, which include reflection, refraction, diffraction, polarization, and interference. The terms you can use to classify wave include 1. A cycle. A cycle is a complete and flow motion of a particle. A wavelength. A wavelength is the distance between 2 successive crests or trough. The unit of wavelength is meter. The period. The period of a wave is time taken for a wave to perform one complete cycle of wavelength. The unit of period is time. The unit of period is seconds. The frequency. The frequency is the number of cycle which a wave motion covers in 1 second. The unit of frequency is a hertz. Finally, amplitude. Amplitude is the maximum displacement of a wave from its equilibrium position. You can now go through your answers and they are marked correctly. If you got the answers correctly, kudos to you. But if you don't, I bet that by now you'll have all the answers in your memory. Now we go into the objective or specific objective of today's lesson. By the end of this lesson, students are expected to know 1. Definition of light wave. 2. Sources of light wave. 3. Transmission of light wave. 4. The phenomenal electrolinear propagation of light wave and the evidences to support them. 5. Diffraction and laws of diffraction of light. And 6. Catalysis of images formed by a plane mirror. Now we go back to the topics proper. What is light wave? A light energy is a form of energy known as luminous energy. Light energy is a form of energy known as luminous energy. It causes sensation of vision, enabling us to see objects around us. For example, if you enter a room and you want to see an object inside the room, you can flash a torch in a dark room so that you can be able to see that object. Please, I would like you to demonstrate this at night. Use your torch or your candle and enter a dark room. You will be able to observe everything inside that room. We have luminous and non-luminous objects. Luminous objects are objects that emit light on their own accord. They emit light in such a way that other objects can be seen through them. We can classify luminous objects into two. We have self-luminous objects or natural luminous objects. Self-luminous objects are objects that emit light on their own accord. Examples are the sun. The light from the sun can reach us anywhere we are. We have the star, we have the fireflies, we have some deep sea fishes. We also have artificial luminous objects or man-made luminous objects, which includes the candle, the electric bulb, the lantern, and so on and so forth. We also have non-luminous objects. Non-luminous objects are objects that does not emit light on their own accord. They can be seen by the light from other luminous objects. Examples are the bulb. You can see we are seeing the bulb with the help of the light from the sunlight. The wall, the chair, our faces, and so on and so forth. We're also going to look into transmission of light. Transmission of light. When light falls on an object, three things are bound to happen. Is either the light passes through the object, or the light is absorbed by the object, or is being reflected back. And these properties of light when it falls on an object classify every object into three main categories. One is what we call transparent objects. Transparent objects are those objects that allow light to pass through them in such a way that other objects can be seen through them. For our layman's understanding, we hear transparent. It means something that we can see through, that light can pass through. Example, the clean water. That is why when you look into the water, you can be able to see even the bottom of the water. We have plain glass. That is why you can be inside your class and you can look out through the window, whether the window are closed or not, because the glass there are transparent. We also have translucent objects. These are objects that does not allow light, that allow light to pass through them, but the light is not large enough that other objects can be seen through them. Yes, they can allow light to pass through them. But the light is not enough to be able to see other objects through them. Example, we have the frosted grass, the oiled paper or tissue paper that is soaked in oil. We also have an opaque object. An opaque object are the objects that does not allow light to pass through them. Example, the board, the wall, the human face, their locker, their chairs, their table, and so on and so forth. So, this light we are talking about passes through medium and also through a vacuum. And a light ray is the path or the direction which the light energy follows. A light ray is the direction or path through which light energy flows. And light ray can be represented using a straight line that has an arrowhead that shows the direction of the light energy. You can see this is a light ray. When we have collections of light ray, it is called the beam. A collection of light ray is called the beam. And the beam are three types. We have parallel beam. These are the light rays that move parallel to one another. They are called the parallel beam. Please, whenever you are driving a light ray, make sure that there is an arrow that shows the direction of that light energy. The convergent beam are when the rays of light that comes out from a source converge at a point. Such rays can be produced using a hand lens. We also have a divergent beam. A divergent beam that separate out as they come out from their source. So these are the different types of beam. We also have what we call the rectilinear propagation of light. Rectilinear propagation of light is a phenomenon that shows that light energy travels on a straight line. I believe in SS1, we talked about motion, we mentioned rectilinear motion. Just like rectilinear propagation of light is telling us that light energy travels on a straight line. We have some natural phenomena and evidence that we can use to explain this rectilinear propagation of light, and one of them is shadow. We all know what is shadow. When we are walking under the sun, we can see our shadow being cast by the sun. And what is shadow? A shadow is an area of land or portion of space where light energy cannot reach as a result of the obstruction by an opaque object. As a result of what? An obstruction of light by an opaque object. What happens is that when light rays are moving, and if there is any obstruction of an opaque object, it will not allow the light to pass. What the light will now do, the light will now cast the shadow of that object. And that shows you that light energy travels on a straight line. Because if not, it would have been diverted. Another phenomenon is what we call the eclipse. Eclipse. Eclipse is a shadow formed by one heavy object and another as a result of what? Obstruction of one opaque object to another. The heavenly bodies we are talking about is the sun, which is the source of the light, the moon, an opaque object, and the earth, which is also an opaque object. We have two main types of what? Eclipse. We have solar eclipse. This occurs when the moon is between the earth and the sun. When the moon is between the sun and the earth, in such a way that the sun will now cast the shadow of moon on the earth. We also have what? Eclipse of the moon, which we also call lunar eclipse. This occurs when the 8th comes between the sun and the moon in such a way that the light from the sun will be obstructed by the 8th. And because the light can no longer reach the moon, the 8th will now cast its shadow on the moon. So we also have some artificial ways of illustrating this electrical propagation of light, which we can use pinhole camera. We can also use a bent pipe and a straight pipe and allow light source to pass through them. You can see that the light can be seen at the other end of the pipe if it is straight pipe, but if it is bent pipe, it won't come out. You can also use a 3 cardboard sheet with a pinhole at the center aligned on a straight line. You can see that when the holes are on the same distance, you can see light through them. But if they deviate, you can no longer see the light. So these are the evidences that shows that light travels in a straight line. Then finally, we talk about the reflection of light. As you all know, that reflection is what? Thrown back of light when it hits an obstacle or an obstruction. A throwing back of light layers when it hits what? An obstacle back to its source. And we have 2 laws of reflection. One of them is what? That the incident ray, the reflected ray, and the normal are the points of incidence, all lie on the same plane. I repeat, the incident ray, reflected ray, and normal are the point of incidence, all lie on the same plane. The second law said that what? The angle of incidence is equal to the angle of what? Reflection. The angle of incidence is equal to the angle of deflection. I will give you a typical example of how reflection of light occurs on a plane mirror. When light falls on a plane mirror, there are some characteristics of images that will be formed. One is that the size of the image must be equal to the size of the object. 2, that the distance of the object from the mirror must be equal to the distance of the image from the back of the mirror. 3 is what we call the lateral inversion. The image will be lateral inverted, in the sense that if you are combing your hair in front of the plane mirror with your right hand, the mirror will be combing it with your left hand. Then we say that the images are what? Visual. We say I want to use the characteristics of images formed by a plane mirror to explain to you what reflection is all about. One is that the size of the image must be equal to the size of the object. 2, the distance of the object from the mirror must be equal to the distance of the image from the back of the mirror. 3 is what we call the lateral inversion. That the images are lateral inverted, meaning that if you are combing your hair with your right hand on the front of the frame mirror, the mirror will be combing it with what? With the left hand. That is the image. Then we say that the images are what? Visual. And what are the visual images? Visual images are those ones that cannot be caught on a screen. That is why if you are in front of the frame mirror, you will see yourself at the back of the frame mirror. But if somebody goes to the back of the frame mirror, the person cannot see you, because that image is what? A visual. It cannot be caught on a screen, although it is nevertheless visible to the eye. Then that is why we say that our image in a frame mirror is what? Is visual. And then these are the characteristics of what? Images formed by a frame mirror. Magnification is 1, which shows that what? The image height must be equal to the object height. 2, the distance of the image from the mirror must be equal to the distance at the back of the mirror. 3, lateral inverted, visual image, and what? Elect or upright image. So with this, I believe that you can be able to explain what light energy is all about. I believe that if you go back to our specific objective, that I've been able to know the diffusion of light, as we said earlier, the sources of light, the transmission of light, the general propagation of light, the evidences that shows what the general propagation of light, and finally, the reflection of light and the properties of images formed by a plane mirror. Thank you, my wonderful student at home. Bear this in mind that what? Repetition is the mother of studies. Keep working. Stay safe. Observe all the directives given to you so that at the end of everything, we all have stories to tell. Together we are going to achieve more. Our next topic will be on the refraction of light. I want you to go and read ahead so that when I come, it will be a kind of a revision to you. Thank you for listening. I still remain my humble self, Engineer Elias Okoli, your physics teacher. Thank you and God bless you.
Rosa Mystica High School.